Today we want to look at a few more examples of solving equations by reading the expression, then performing inverse operations in reverse order. So I want to look at another quadratic equation, but I want it to be in vertex form. So let's look at the equation. Let's suppose we have 3 times x minus 1 squared plus 4 is equal to 5. Had to come up with a number and I was coming up short. So here's what we notice. We notice that there is an even exponent. So we might have 2 or 0 solutions. That's the first thing that we identify. So there's an even exponent. So we'll have 2 or 0 real solutions. So this is not something that we're applying right now. We're just things that we notice about our equation. Now let's read the expression to see how we turn an x into a 5. That's what's going on in this equation. There's some stuff happening to the x, and then we get a result of 5. So let's read the expression, turn an x into a 5. So we have x minus 1, so the first thing is a minus 1, and then we square the results and multiply by 3. In that order, because exponents go before multiplication, unless grouping symbols tell us to change the order. The grouping symbols around the x minus 1 are what's telling us to do the minus 1 first. But that's what those grouping symbols were there to tell us. So now we do an even exponent of 2. That's where our 2 solutions are going to show up. And then third, we'll multiply by 3. And fourth, we'll add 4. So here are the 4 operations that turn an x into a 5. And this is how we'll come up with our plan for doing inverse operations in reverse order. So we want to turn a 5 back into an x. So first we'll invert plus 4 with the minus 4. Second, we'll invert multiplying by 3 with dividing by 3. Third, we'll do the inverse of a square, which is a square root, or a 1/2 power. And fourth, we're going to add 1. Now notice that the square root is when the 2 solutions will show up. That's when the solution set splits into 2 or 0, or we'll find out that there are no real solutions. So that the fourth inverse operation of adding 1 will have to be done to 2 solutions if we end up with 2 solutions. So let's find out. We're going to start with 5. We're going to start with a 5. And the first operation is to subtract 4, and that'll give us 1. And then we'll take the 1 and divide by a 3 to get 1/3. And now we're going to do the square root. Here's what we notice. We're going to have 2 solutions. When we apply the square roots, we're applying it to a positive number. So we're going to end up with 2 solutions. A lot of times we see this as plus and minus. So the step right before the square roots, we're going to do the square root of a positive, so there will be 2 solutions. Because we're going to do the square root of a positive 1/3. But we're going to need a calculating machine for this because I don't offhand know what the square root of a third is. So I'll take a 1/3 and raise it to the 1/2 power, making sure I put my fractions in parentheses. So 0.577, we'll call it that, round to the nearest 1,000. So I'll take 1/3 and raise that to the 1/2 power, and we get 0.577. But because we have an even exponent, we'll also get a negative 0.577. So to each of these solutions, so to each of these values, we have to do the last step, which is plus 1. So I have to do 0.577 plus 1, which is a 1.577. But I also have to do negative 0.577 plus 1. So I'll have to do a negative 0.577 plus 1 to get the 0.423. So those are our two solutions. So we'll say x equals 1.577 and 0.423, 0.423. We ended up with two solutions because when we got to the square root step, we were doing the square root of a positive number. So that's what led to two solutions. Remember, this is a lot of writing to come up with these two solutions, but this first two columns take place in our mind. We're just thinking these first two columns, and the third column takes place on our calculator. So these first two columns we're just thinking about. And the second two columns take place on our calculator. So this is just what our calculator is thinking. I don't know if my calculator actually thinks. It doesn't seem to want to communicate with me in any fundamental way except for answering my math questions. But in my mind, my calculator is thinking about these things. But the 1.577 and the 0.423, those are the numbers that we want to report. Those are our solutions. If we got to the step where it would split off into two solutions, and the next thing we were going to do was apply the 1/2 power or do a square root, that's when we say that there's going to be no solutions. So for example, let's suppose that I had 5 times x plus 3 squared plus, that one can stay plus 4. Let's suppose this is supposed to equal 1. So we're just shifting everything around. So we want to be able to read the expression. We want to be able to read the expression, perform inverse operations in reverse order. Once again, we notice that we have an even exponent, so we'll have 2 or 0 real zeros. Where we're trying to get with this is to look at this equation, and instead of writing all the stuff down, just grab our calculator and say the first thing that we're going to do to the 1 is subtract the 4, and then we'll divide by 5, and we'll have a negative 3/5, and now we're going to have no solutions. Because now the next thing we would want to do is a square root of a negative number. That tells us that there's going to be no real solutions, so we're done. We want to decide quickly if we want to notice quickly if there could be a possibility of no real solutions, and then find that out as fast as possible. So going back to the previous problem, we want to be able to read the expression and perform inverse operations in reverse order. So I'll first take the 5 and subtract the 4, and then we'll divide 4 by 3, and then we'll do a 1/2 power. So we'll do a 1/2 power. This is one of the reasons, since I I want us to learn how to use the calculating machine. This is one of the reasons I prefer 1/2 power rather than square roots, because I could just start asking for the 1/2 power, and it'll do 1/2 power, the 1/2 power of the answer. The square root has to go before I type answer, so it would work out a little bit differently. So this gives us the 0.577, and then to this we'll add 1, but we'll also have to have a negative 1/3 to the 1/2 power, and we'll have to add 1 to that as well to get the 0.423. So to recap, I prefer a 1/2 power because the thing that I'm raising to the 1/2 power is right there on the screen. I could just ask it for the 1/2 power. If I wanted to do this with the square roots, I would say 5 minus 4, and then divide by the 3. And then I'd have to take the square roots. So I'd have to hit the square root button, and then I'd have to hit the second and answer to get the square root of 1/3. I could have just noticed that it was 1/3 and done square root of 1/3 as well. But I like just to push the button that represents the next operation. Any questions? And although in the no real solutions example, I did say we wanted to combat this quickly, but quickly is not the point. The point is understanding what's going on. I think a lot of times traditionally these problems in this vertex form would be taught by multiplying everything out and using the quadratic formula, which I do not approve of. I think the quadratic formula is trash. I think this is a better form to start from because I think it really gets at the idea of function and inverse function. And it also really gets at the idea of when an inverse function is not also a function. To take a look at what the writing would look like, we already know what the answer is, but that doesn't mean that we should stop analyzing the problem. We notice that there's an even exponent, and that means 2 or 0 solutions, real solutions. Turning an x into a 1 in this case would require these 4 operations. First, we would add 3. Second, we would raise to the second power. Third, we would multiply by 5. And finally, we would add the 4. The inverse operations in reverse order to turn a 1 back into an x. First, we'll subtract 4. Second, we'll divide by 5. Third, we'll do a square root or a 1/2 power. And fourth, we'll subtract 3. Once again, noting that there's an operation after the square root. And since we're solving an equation, that might give us 2 solutions. But if the step right before the square root has a negative, then we're done and we see there's no real solutions. And that's what we're going to find out when we start writing everything out. 1 minus 4 is -3. -3 divided by 5 is -3/5. And now we know we're done. The next thing is a square roots, and so now we can see there will be 0 solutions. Because we're doing a square root of a negative number. All right, so those are the 2 examples that I wanted to do today, both quadratic functions, or quadratic equations, excuse me, both quadratic equations, because we have probably in our history seen quadratic equations before. And I want to make sure that we don't just automatically start thinking about the quadratic formula, because the quadratic formula is, in fact, trash. It's not as bad as PEMDAS, but it's pretty bad. We're humans. We're better than that. Quadratic formula is a machine thing. All right, that's going to do it for today. I will see y'all on tomorrow, and thanks for playing.